Okay, so an ant is walking along the edges of a wire frame in the shape of a triangular prism. So he's walking along here. The vertices and edges of this frame can be represented by the graph below. That's this graph. Write down the adjacency matrix M for this graph. Okay, so what we're gonna do, or what's happening here, is essentially, well, it's M. We're going to do M equals, and it's a matrix, so we got to do this. Now I like, guys, to put, and maybe you can even erase this after, but I like to put A, B, C, D, E, F here, and across the top A, B, C, D, E, F. Okay, and you're basically looking at, can you go from A to A? No, because there's no loop here. Like, that'd be a loop to bring you from A to A. Can you go from A to B? Yes, so you put a 1. Can you go from A to C? Yes, so you put a 1. Can you go from A to D? Yes, you put a 1. Can you go from A to E? No, so you put a 0. Can you go from A to F in one go? I mean, obviously you could go through D, A to F. No, so I put a 0. And I do this for the rest of them. So the way I like to just do it is B goes to A, E, and C. So I go A, E, and C, and the rest are 0. C goes to A, B, and F. A, B, and F, and the rest are 0. D goes to A, F, and E. A, F, E, 0, 0, 0. E goes to D, F, and B. D, F, and B, 0, 0, 0. And F finally goes to D, E, and C. D, E, and C, 0, 0, 0. And note, this is it's symmetrical about across from these zeros here. So 1 1 1 0 1 1 1 1 1. Yeah, you can see the symmetry there, and that's a nice way to just check if you're right. So that's it. That's the adjacency matrix. I'm sure if you left the A, B, C, D, E, F, they'd still give you the marks, but you might want to just erase them because they're not actually, it's not part of the matrix. So there you go. That's the matrix. And that's worth, I think that was 3 marks. Part B then, he says, find the number of ways that the ant can start at A and walk along exactly 6 edges to return to A. So what that means is he could go 1, 1, 2, 3, 4, back to there, 5, 6. That's one way. Or let's try and do another one. He could go 1, 2, 3, 4. I've done the same thing again. I'm gonna have to go back to B. 5, 6. But all those that way counts. In fact, there's loads of ways I could do that many ways. How do I find out exactly how many ways? Well, I have to do m to the power of 6. So on my calculator, I have already set up this this matrix, and I've created the matrix by doing menu, matrix and vector, create matrix. Then I just like to store it as M. So I'm going to store this as capital M. There we go, or small m apparently. Then I press M to the power of 6, and it gives us this. So which of these is the number of ways from getting to A back to A? Well, it's this one, A to A. So it's 143. So it's 143 ways. Now you don't have to write out this whole matrix, but I'm going to say from m to the power of 6, there are, what did I say? 143 ways. 143 ways. Number, by the way. Okay, that's it. That is question 16. Actually, to be fair, that was not a difficult question for the second last question on the paper is supposed to be difficult. That I don't think that was difficult at all, provided you know what an adjacency matrix is, and that obviously the number of ways from getting to one point to another, that where they walk exactly 6 edges, is the matrix to the power of 6, and pick the correct element. Okay, that's it, guys. See you for question 17.